Aloha Algebra 1 students, this is Project 6 Parabola Selfie. This video is going to give you a brief overview of the whole project, and then I'm going to explain in detail part A of the project. So first off, the object of this project is to be able to identify parabolas in the real world, meaning wherever you are in your home or in nature or at school or in a car, and you will be able to just look around and be able to identify actual parabolas that are there, whether it be on a design or in nature or whatever it may be. So if you flip over your piece of paper or the rubric, number one, it's going to tell you the deadlines. So we're starting part A on April 20th, Thursday, and that will be due by the end of class on April 21st. Part B is April 26th. Part C is April 27th. Part D is April 28th, and Part E is May 3rd. And again, this project will be done solely in class and will be due at the end of each period, unless it's something like the 26th or May 3rd. That's going to be a couple days that we'll be working on it in class, and then again due on all of these dates. So part A is just identifying the selfie. B is uploading it into our Desmos graphing calculator and figuring out what the equation is in vertex form. C is identifying parts of the parabola while it's in Desmos. And then part D, we're going to take your vertex form and we're going to also create factor form. And from factor form, we're going to distribute that and create standard form. And so eventually we're going to end up with all three forms of your one parabola. At the end of your project, we're going to put it all together on one slide, parts A through D, that will include all of the following information. Okay, so let's talk about part A. Part A, we're first going to find a real life parabola. So let's talk about the characteristics of a real life parabola. This is probably the most famous parabola. In fact, this is a double parabola. As you can see, the fries on the McDonald's Golden Arch is creating two different parabolas. Here I have this pink parabola, and on the other side I have this blue parabola. This is the St. Louis Arch. And one important detail or characteristics of a parabola is that it hits at some point and it goes outward. Whether it be a parent function or reflective parent function, it moves outward. This is a bridge in Australia that we were on in 2019. And as you can see, this is a parabola right here. It has a point and it goes outward. Actually, sorry, let's go backwards. It's actually better if you looked at the inside of this parabola right here, the bottom part. That's more of a parabola. Here is the entryway of a home. Again, a nice parabola. And for this one, you could actually use the outside of the parabola or the inside of the parabola. Here's a slingshot, and the whole slingshot is not a parabola, but just this part here that holds the rubber band. We start at a vertex and move outward. Okay, here on a car, if you look sideways, we have a point right here with a parabola that goes upward this way. A parabola that goes upward. Again, we need it to be symmetrical. We need it to come to a point and we need to go outward. Here is a flashlight with its reflective light forming a parabola. We have a point and it moves outward. Here's a fountain. We can see, again, here's our vertex and it moves outward. And it's also symmetrical. Okay. So remember that if I have shown you an example, you are not allowed to use my examples for your actual project. Okay, this is an example of, these are going to be examples of non-parabolas. So they kind of look like a parabola. They're almost shaped like a parabola, but they're not parabolas. So this is an arch. And I think this is in Rome. Rome or Paris, one of those two. Okay, so if you look here, someone might say, oh, that's a parabola. But there's a couple things wrong with it. Number one, here, it moves downward and straight downward. It does not move outward. If I was to put this into Desmos and try to find the parabola portion would only meet up for the very top. And you see how it's not exactly a parabola there? Yeah, the parabola is probably like from just this part inward. And again, it moves downward, straight downward. Okay, another misconception about parabolas is that a half circle is a parabola. Remember, half circles are half circles. Parabolas, they have a peak and they go down. They peak and they go down. Or the peak would be the minimum. And again, that's the vertex. If I was to put this on a graph, this is what it would look like. And as you can see, the parabola would only hit from that part to that part. It wouldn't hit any more. This is a slinky. And again, the same thing, right? It doesn't really peak right here. It doesn't really have a vertex. It just kind of goes rounded. If I was to put this against a graph, you could see that we can line this part up, but really nothing else with our parabola. Okay, so the first thing you're going to do is you're going to find a parabola. Now, I'm actually going to suggest that you go and you find 3 different parabolas so that when you come in back into class, we can talk about your parabolas and you can decide on what's the best parabola that you find. Okay, once you find it, on Friday, what we're going to do is we're going to upload it into a Google Doc that's in your Google Classroom. And when you find it, you need to do 2 things. You need to take a picture of the parabola and you need to take a selfie with it. Then we're going to upload it. So this is an example of my selfie. I walked around my house the other night, and in my daughter's room, I saw this bottle of fingernail polish remover, and I thought, oh, right there, that's a parabola. As you can see, it's more like a drop, but right here, we can cut it off. Here's a better picture. So this way, this is our parabola. It has a vertex, it has a point, and it moves outward, and it's going to move outward to about there. It's going to move outward to about there. So again, you need to do 2 things. You need to take a selfie with it, and you need to take an actual picture with it. So again, while you're walking around outside in your home or at school, you're trying to find 3 different parabolas, and you're going to take a selfie with it, and you're going to take a picture of it, the object itself. So parabola, selfie. Now, another thing you were going to have to do is you're going to have to explain what the parabola object is and where you found it. So just like I said earlier, this parabola is a label on a bottle of fingernail polish remover, and I found it in my daughter's bedroom. Another thing you're going to have to do here, hold on, is you need to find the dimensions of your parabola. And so I want you to find 2 different dimensions. And the dimensions I want you to find, number 1, are the height. So we're going to measure the height from the vertex to the edge of the parabola. Now remember that I said that this is a drop, but up to this point, it is a parabola. And so I'm just going to say my parabola is just this point here, from there all the way to there. Again, from this point all the way to this point. The second measurement you have to do is the length. So you're measuring from one point to the other, and then from that length all the way up to the vertex. Here's an example of if I was to use sorry, not an example. So eventually, for part A, this is everything that's going to be required. Number one, your object or your parabola. Number two, your selfie. An explanation of what the parabola is and where you found it in the real world. And then also the dimensions, again, so the height of it and the length of it. Okay. If you have any questions or concerns, please make sure that you're coming in and asking questions and getting some clarification. Have an awesome day.